What up, Doug?
Not much, Mitch. How are you? How's your day?
I'm doing well. Those are some nice plants you got in the background there. You
I
grow them yourself?
I did. Yes.
Oh, very
I never
nice.
have to worry about them dying either.
Wow, I'm impressed.
You got some serious vinage going on behind you there. I like
Oh
that.
yeah, we take the vinage seriously over here. Doug, I got a question for you.
Okay.
What is up with these eVTOLs? You know what an eVTOL is?
From my understanding, it's electrical vertical takeoff and landing aircraft, as
Uh-huh.
your slide shows right there. So
Yeah. Okay.
it's
Yeah.
definitely becoming the Jetsons very quick.
All right. So we got flying cars.
Yeah. Yes.
Cool. I like to think of myself as an automotive man, so I'm all about flying cars.
Well, the two are becoming one.
Yeah. Well, I think HBK has definitely been involved with a lot of electric vertical takeoff and landing. And I know internally we get a lot of questions. What is eVTOL, or what is it? What are they doing? Are they real? So I
Right.
think maybe we just jump in and talk about what they are a little bit.
Yeah. Let's do
All
that.
right. All right, let's do that. So, I mean, what is an eVTOL? And I think that's a little hard to define because they come in so many different shapes and flavors, but at the end of the day, they're electric. They take off vertically
Hmm.
and they land vertically, as the name states.
Yep. It's a great concept.
Yeah. Yeah. And I mean, the interesting thing is what we've seen something like a couple hundred different companies entering in this space.
Yeah. It's interesting to see in the news how much funding these companies
Yeah.
are getting and the interest that's being shown of this new sort of era that's being issued in here.
Yeah, yeah, and I think one of the interesting things is that take off kind of vertically or at an angle, but they do achieve forward flight at some point, and that gives them ranges. We're seeing advertised in the 15 to 100-mile range.
Right.
Definitely a lot of challenges with them, but some really interesting applications. I mean, I've heard of them being targeted for medical industry.
Uh-huh.
Um, I think also, looking at kind of the air taxi to get you from city center to an airport or maybe a different spot in the city. I mean, have you heard of anything else?
Well, it's interesting you mentioned the medical part. Um, my understanding, one aspect of the medical world that may get replaced real quick by these vehicles is an ambulance.
Yeah,
Because in large cities, okay, the traffic may be so bad you can't get to the wreck, or maybe once you got there, okay, how do I get them
yeah,
to hospital? With these vehicles, that's almost not an issue.
yeah. I think it's a really interesting aspect. I mean, then you see kind of there's the obvious kind of military transport and delivery side of it. Even on the civil side. But a couple of notable things about these vehicles is they are electric. So right now we're seeing battery powered. There is definitely discussions around hybrid or fuel cell, but they have completely new structures. We'll talk in a minute about the different structures. They have completely new propulsion. You see a helicopter. It's got what, one rotor on top, one on the tail wing.
Right.
How many does this bad boy have?
I don't know.
12.
Yeah, 12. So
Um, and then we're seeing a bunch of different propulsions. So it's really a lot of really clever engineers with a lot of clever ideas have been coming together to figure out how can we lift 2 to 10 people and maybe 1,000 kilograms
yep.
and move it 30, 40 miles. So I think the question of what is an eVTOL is it's for transporting people through the air, short distances, low altitudes. With flight patterns probably similar to a helicopter. And I hate to make that comparison, but I think it's the mission profile is similar.
I think it's very, very similar.
Well, and I think the one we didn't mention was delivery. Definitely Amazon and FedEx and UPS are all looking at this type of thing very publicly.
Well, and you mentioned the word public. I think
Yeah.
it's going to be a very interesting topic as these companies move forward.
Yeah.
My understanding is they're going to be piloted, but with
Hmm.
the intention to make them autonomous.
Yeah.
So I think public acceptance is going to be um, an area that's going to be very interesting as these things move forward.
Oh yeah. Yeah, and even like the noise pollution that they're going to create, or the line of sight pollution on a nice cityscape. So yeah, I think let's get back to that because I think the first thing to maybe cover is what do these aircrafts look like? We mentioned previously that they come in a bunch of different flavors. So at the end of the day, I think we could group them into like four different categories, and this is not inclusive, and I'm sure somebody will say we have this really different platform. I can think of a couple.
Right.
Uh, but we got the multicopter. Um, this is kind of like your drone. The rotors don't rotate, but the vehicle rotates.
Correct.
Yeah, I think these are probably the simplest because they have the fewest moving parts. I don't know.
Yeah, no, I think the four, we'll call them classifications you've got
Yeah,
shown there, pretty much all the eVTOLs that I've seen sort of
yeah,
fall into one of those four categories.
yeah. Yeah, so we got the multi-copter, we got the lift and cruise. This one's fun. Everything's fixed, but you have, rotors that lift, and then once you're lifted, you kind of engage a pusher motor, and
Mhm.
then you eventually turn off the lift motors, and then you're just in regular forward flight like a standard aircraft.
Right.
And I think it's interesting because these guys actually could enter the market as a standard aircraft if they desired. So might be some business model stuff there.
Yeah.
We got the tilt rotor. I think my personal favorite.
Well, and it's interesting about the tilt rotor. It's not necessarily the first time we've ever seen this.
Yeah,
The military, what is it? Is it the Osprey
yeah,
that has done this already? Now, it's not with an electric motor, and
hmm,
it's a larger, much
yeah,
larger aircraft.
yeah,
Concepts there. So
yeah,
they took and adopted it or adapted it, however you want to look at it, to a smaller aircraft that flies lower and
yeah,
slow. But
yeah,
like you said, for air taxis and things like that, you don't need to go Mach 1.
yeah. Well, I think it's interesting, comparing to like the Osprey, or I can't think of the name of the Leonardo one. Those have two rotors, and they're big honkers.
Yeah.
Where we're seeing a lot of these eVTOLs go to, again, that kind of distributed redundancy and propulsion, the distributed weight, um, where they have, in this instance, I think it's six rotors that are all kind of casually going into that forward flight.
Right.
You add a level of safety, you add a level of distribution that I think can lead to these being quite successful. On the tilt rotor, though, I know with the Osprey and some of those, they had quite a lot of stresses on the structure making that
Oh,
transition, and I'm
oh,
sure that'll be a challenge.
yeah. Well, and I think the FAA is going to make sure that that is looked at to make
Yeah,
sure from a certification standpoint that all the I's are dotted and T's are crossed.
absolutely.
Because the last thing, especially if you're going to go down the air taxi path, is to have some of these bad boys fall out of the sky.
Oh yeah. I mean, again, back to that public perception, that safety. Yeah.
Yeah.
But I think this is a really cool concept, and interestingly enough, like none of these are new. Maybe the ducted vector thrust. I mean,
That
this picture's from Lilium, and this is Lilium's aircraft, but I personally think this one's real clever.
Oh, it is. It is, and in my opinion, it sort of is the closest one to a Jetson type, you
Yeah,
know,
yeah, yeah.
layout. But
Yeah, where you've got, I think they've got quite a few fans that, push down and then the whole fan assembly rotates.
yeah,
Um, and I'm no aerodynamics expert, but I have a feeling it's quite interesting from the airflow perspective.
yep.
But yeah, I mean, there's 100 different flavors and geometries, but I think they all fall vaguely into one of these four categories. But kind of coming into the next point is, what are some of the challenges? And Doug, your expertise is structures. I mean, are any of these structures remotely close to a traditional aircraft?
There are a few that's close. You could throw out the X-57,
Yeah,
but it's not a vertical takeoff and land.
yeah,
So it's went down the path of being just a conventional aircraft with
yeah,
an electric motors holding
yeah,
the wings.
yeah,
So you've got some of those. I think Betas is close
yeah,
to a conventional aircraft, but outside of that, you're right.
yeah,
The- From a structural standpoint or structures
yeah,
standpoint, they are very different, and I think that's some of the challenge the FAA is having.
yeah,
The multicopter. I
yeah,
mean, okay, is it a helicopter? Is it an airplane? It's
yeah,
obviously
yeah.
so. What FAA regulations for certification does this aircraft fall under?
Yeah. Well, I think that leads us into the next point of, what are the challenges in development and looking at these brand new structures. We've mentioned that they're electric. There's not many electric aircraft in the sky.
Right.
Um, and the ones that are not certified. But you're also adding, a new lift methodology, a new push methodology, a level of electrical complexity that we've not really encountered before. So purely from the development and getting things working, we have these new powertrains. We're adding batteries in, which kind of falls into weight, but
Yeah, that's
we have to
scary.
certify batteries.
Well, and battery is also from a safety standpoint.
Yeah,
The
absolutely.
you hear about cars,
Yeah.
just spontaneously catching on fire. You definitely don't want that in this world.
No. Well, and then you add in the structures, and we're not just making new structures, but I think a lot of people are engaging in new materials, lightweighting,
Oh yeah,
and that all has a structural effect.
oh it does. And
Yeah.
you're using composites that, okay, we know them, we know their material properties, but not as well as we do
Yeah.
the conventional aircraft.
Yeah. And then there's the weight aspect because they're electric, because they're smaller profile. We want to get that mission profile to be something useful. So, looking at the weight and how we remove weight out. I mean, it's almost the early days of aviation where we're looking at, yeah, all right, we can get this thing in the sky, but can it go as far as we need it to, or can it carry the payload?
Yep.
Then we have the certification. I mean, once we've developed the aircraft, we need to look at certification. And my area is the electrical, and I can assure you the power quality specifications for conventional aircraft and traditional aircraft need to be modified or looked at heavily because we have more electrical systems, higher frequencies, broader distribution. I mean, there's a good framework, but it's not the right fit today, and we need to understand that better and make sure that these aircraft are electrically safe and redundant enough if we have motors go out that they can stay
Yeah.
stable in flight.
Yeah, and the structural part of it, that's definitely a challenge from a certification standpoint.
Yeah,
And the thing that I think may come into play is the speed of the FAA rolling out these new
yeah,
regulations, these new certification uh, documents, because this is moving forward very fast.
oh yeah, oh
But
yeah.
they're not legally going to be allowed to fly until these aircraft are certified.
Yeah, and I mean we know that the Air Force with the AF Works program is pushing some of this from the non-public side, but at the end of the day, they certify as well. So
Oh,
hopefully we can learn from these different organizations.
well, hopefully the FAA and the Department of Defense, because I think
Yeah,
that's where aircraft on the defense side sets falls under the DoD,
Yeah.
where the civil side falls under the FAA.
Yeah.
Now, I think just recently, within the last week, EASA rolled
Yeah.
out some proposed noise
Yeah.
regulations.
Absolutely.
It's going to be
Well,
interesting
that,
to see how that gets adopted here in the US.
yeah. And those noise specifications, I mean, it's these aircraft are pretty quiet, but
Mhm,
the props still have, that kind of distinct prop noise.
mhm.
And then we start talking about frequency and how often these things are going by and what the tones and pitches they're putting off are. So it's less of a decibel level safety and more of a is this annoying? Is the neighborhood gonna accept this?
Well, and that leads into the third category there, public
Yeah,
perception. Okay, it's not just the occasional, um, 777 or 787 flying over your house as it's going in for landing or approach.
yeah.
Uh, Now you could have hundreds of these vehicles flying around. So
Oh
you
yeah,
to a sound quality issue. It may not be
yeah,
loud, but it may be annoying as hell.
yeah. I completely agree. It's that public perception, and then there's the safety aspect. I mean, I know at one point, um, we had air taxi services in New York and LA that would take, from the top of one building to the airport or something. But there's a couple of really tragic crashes in the late 70s, early 80s,
Yeah.
that completely tanked that industry. I mean, two crashes absolutely annihilated an industry. And so safety, I think, is the utmost concern for the business viability and for the public perception of this.
Yeah. Well, and then you touch on that third bullet item, you know, my backyard. Because if you look at urban air mobility, so you take the word urban,
Yeah,
now I'm taking a relatively quiet neighborhood that was relatively private. Now I got people flying in an eVTOL
yeah.
lower to my house,
Oh
can
yeah,
see everything that's going on, emitting noise and everything else. I got a feeling
yeah,
that's going to be another aspect.
yeah, yeah. Oh yeah. And then the last 2 points we have here, infrastructure and business model. These are a little out of our wheelhouse, being the kind of aircraft technical guys, but these things are new and novel. They're heavy, and there's not that many vertiports just sitting around. So I mean, there needs to be a completely new infrastructure to support the different business models these guys have. Are you operating like Uber? Are you selling to airlines? Who's running the show? So the infrastructure and business model. I mean, that could be a 10-hour dissertation on itself.
I do know that it appears they're starting to try to wrap their brain around what that infrastructure looks like.
Yeah,
And short term, I think they're going to try to use like vertiports that's already there,
yeah,
you
yeah,
know.
yeah,
So, but yeah, and especially that last one, business model. It's like, okay, I could maybe see myself if I lived in an area where traffic was horrendous and it took,
oh,
an hour and a half to go 5 miles,
yeah,
to pay a little more to get there faster.
yeah,
If you don't make that economical, I mean, the only way this is going to be successful is if the public buys into it.
yeah. Well, that's where I see, some of this getting started with the ambulances, with the, fast time delivery, organ delivery, I think of,
Yeah.
some of these areas that have a little less price sensitivity, but are, life-saving critical. But yeah, the public perception, that's going to be a wild one. So we will see. And Doug, I think we should close out with why we did all this and why we put together. HBK is a test and measurement company. I don't think we mentioned that at the beginning, but we sell test and measurement equipment to help engineers, validate designs, help people through the certification process, and we sell instruments for making measurements, and we have quite a few actually applications that just fit really well from traditional aerospace or from traditional automotive background into eVTOL. I'll lead off talking about the two that are kind of my babies.
Okay.
Power quality and fault testing for electrical systems. Power quality has always been a really important factor for aircraft certification. Whether it's DO 160 or SAE 40. Looking at, is the electricity in this aircraft good enough to fly? And if something electrically fails in my aircraft, do I have redundancy? We offer some really cool stuff for testing flight sequences to bring that information back to certifiers, to the engineers, and then electric powertrain development. With these new motors, we're looking at lightweighting, we're looking at increasing efficiency, increasing redundancy, increasing reliability. There's a lot of R&D and development that goes into that, and we have some really, really great solutions for measuring that efficiency, measuring that performance, so your engineering team can develop that really high-end, lightweight product. So electrically, we have a lot of cool measurement solutions for ensuring your product is good and can go to market.
Yep. Nice. Well, and that fits right in with like ground vibration testing, better known as GVT. That's actually part of the existing FAA regulation. And the reason that is because these aircraft can encounter flutter. There's classical flutter, there's whirl flutter. You have to, oh, I like that example. So you have to quantify that. You have to find out where those flutter modes are and make sure that during flight, these modes are not being excited.
Yeah.
Same with production testing for
Yeah.
propulsion. I mean, you need to make sure that when that propulsion system rolls out the door, that mechanically it's sound. It doesn't have any type of structural
Yeah.
fatigue going
Oh yeah.
on. And we also provide the tools needed to do flyover testing, which
Yeah.
is, I know, going to be part of the FAA certification.
Oh yeah.
So, eh,
That acoustics. Yeah.
yeah, so at HBK, we supply all the tools to from instrumentation, transducers, to
Yeah.
data acquisition, to data analysis,
Yeah.
quantification.
Yeah. And I think I'll jump in on the two that neither of us are necessarily experts on, or the three or four. We got the structural durability and fatigue part. When we think about the safety and redundancy of these systems, we need to quantify these structures to see how many flights they can do before we need to maintenance the structure. So we sell tools for measuring, how much does this wing bend over time to look at that lifetime fatigue. So we have measurement tools and analysis packages to look at that fatigue life. We sell sensors for sitting in the vehicle that we call hums,
Mhm.
that can be used to identify, is something in the aircraft going wrong? So again, we can maintenance them on a healthy schedule without these things, I hate to say it, falling out of the sky,
Right.
to ensure that safety, which also comes into fleet maintenance and prediction. We've got a really awesome software team that uses a bunch of math I don't understand to take HUMS data, to take that durability and fatigue data, and predict when a vehicle needs to be maintained. So looking at fleets and identifying maintenance schedules based on statistics.
I can see
Uh,
that becoming, very important,
oh
especially
yeah,
with the business model of like Joby, where
yeah,
they're not going to sell their aircraft.
yeah,
They're going to fly their own aircraft for air taxis. So they're going to have
yeah.
fleets of vehicles that they need to keep track of
Oh
this.
yeah. Well, and how many parts do you need to have at each vertiport? Do you need 10 widgets, or do you need 4 widgets, or do you need 1,000 widgets?
Exactly.
I mean, even the logistics of it come into this fleet maintenance prediction. It's really cool stuff. And then lastly, controller validation. We have some really cool real-time computers that you can use to test out your flight controller. Um, and look at, if I lose a LRU or if I lose a motor, how does my controller respond? for doing some like hardware in the loop on your controller. And I'm sure somebody at HBK will reach out and say we do something that I completely missed or that Doug completely missed. But we do a lot from electrical to structural to life cycle to software and controller validation. So
Yeah,
um,
and we're not necessarily saying we are a one-stop shop. You know, we are in a certain aspect, but you don't have to use our transducers. You know, you don't have to use our data acquisition. But the thing that I hope you take away from this is the fact that we do make all the parts, so we understand how they work together
yeah.
and how they can be used.
Well, yeah, and I look at it like, Doug and I are not the only experts here at HBK. We're hopefully going to have a video series where we touch into, all of these different elements in a little more detail. But people like Doug and I talk, and we start to understand where does the new propulsion systems and the structures overlap, and it's a lot more places than you think.
Oh, yeah, it really
So
is.
all of these things really blend together, and if you've got a question without an answer, HBK has people who have tested in a lot of different areas and can start to maybe piece together what your unique problems are. And that's one of the things we add in addition to equipment is we've got some really sharp people for understanding these issues.
Exactly. Yep.
Cool. Well, hopefully you guys join us for the other videos where we jump into some of these topics in more detail. Um, well, Doug, we should really get your link in here. You know what? I'm going to edit that in the post process.
I I'll have my own little QR code. That is,
Yeah, that people
um,
need to find Doug.
they don't want to find the dough all the time.
All right. Thank you, everybody.
Thanks, everybody. Have a great day.